Mhm. And I'm live. That is pretty cool. And today is 6th of November 2025, Thursday. And yeah, that is the start intro or whatever. But yes, I am very late today. My bad. There was like no water at my house. Yeah, something happened at the water tank. So yeah, without wasting time, let's just do some questions. And shit, since I started late, I won't be able to stream for long. So yeah, I will only stream till like 5 or 5:30. And also today is a contest. Today is a contest. Division 2 contest. I will be giving the contest with 19,000 other people, 19,000 some other people. This is going to be crazy. Mr. Shit Newell Tumbles is there, and also Mr. Tourist is there. Yeah, this is going to be nice. And also, there is a good news. The LD's question. I did the LD's question. That is like nice, very nice. And I just want to rewrite the solution again. Just yes, why not? TCP and okay, 58 into 30, 5,800, 580. My bad. 580 plus 100, 64, 5,080, 5,580 plus 164, 680 plus 64, 744. Okay, if I'm wrong, that would be sad. Wait, processing and shit, 754. 754 somehow. Okay. Anyways, back to this question. This is what we are going to do. Like, yes, I just want to recreate this once. I did this yesterday and yeah, cool. And then take in n vector and a size n for and reference x and a, take in x to fill in a and ls end to stop the LSP. And now we have long response. Let's say initially equals 0 or no, we need a DP table. We call it long DP size would be equal to n. And we know that DP 0 equals 1 and then we will start going from the last element. Okay. Yeah, from the second element, I smaller than n, I plus plus. And if AI the current element is smaller than the last element, then dp I equals dp I minus 1 plus I plus 1, else dp I equals dp I minus 1 plus 1. Like, yes, that is the whole answer. And response would be accumulate a dot begin and a dot end and accumulate all of that onto a long and then output the response. Okay, cool and shit. Okay, compiling and wrong answer. Shit. I messed up somewhere. If the current element is smaller than the last element, then the answer should be the last element plus I plus 1, which is shit. Yes, here instead of A, we have to give like DP makes sense. And Cool. That does work. Hello. Yes. Today I was late because something happened with the water system through which water comes to our house, and there was no water, so I couldn't bath. And this problem was happening since yesterday. So I didn't bath yesterday also. I just wanted to stream after taking a bath. Yes. And also like the number two thing. And this is running. And I'm like very proud of this solution because we did struggle on this question and now it works. And the simplicity, look at this. This is just how many? 16 lines of code. But under those 16 lines of code, the thing is very cool. And also, have you worked with Raylib? You are into game dev, right? So I recently discovered Raylib by Mr. Raysan 5, and Raylib is pretty good. Raylib is actually pretty good. And let's do some random 1600 rated questions now. And yes, today is a contest, so that is going to be crazy. Let's do Lost Soul. Cool. And yeah, Lost Soul with a stopwatch here. Cool. Okay. Cool. You are given two integer arrays A and B, each of length n. You may perform the following operation any number of times. Choose an index I, yes, in the range except the last one, and set AI equals BI plus 1 or set BI equals AI plus 1. Okay, okay, one of these things. Before performing any operations, you are allowed to choose an index I and remove both AI and BI from the array. This removal can be done at most once. Okay, from let the number of matches between two arrays C and D of length m be the number of positions there such that this. Your task is to compute the maximum number of matches you can achieve. Okay, we have to make these things equal to each other, and before performing any operation you are allowed to do to remove one index from both the arrays, and we can only do this at most once, but this operation we can do multiple number of times. Okay, okay, and we are not making the things which are at the same index equal to each other. Okay, this and this are equal to each other. Okay, we can change this into a 2. That would be nice. And yeah, that would be nice. Maximum number. When would we like to do this change? This can be used to remove some uh, element from the middle of the array, from both of the arrays at the same index. Okay, here we can make shit. We cannot make anything. Shit, these are shit. I guess the answer for this one is 0. For the third one, yes, it is 0. For this one, they are saying the answer is 3. I guess we can change this into a 2. So 2, 3, 2, 3. That would be nice. But can we do anything else? How can we achieve 3 here? Whatever this value is, this number can become equal to this number. and then this number can become equal to this number, and this number can become equal, and then this number can become equal to this number. So this number essentially can become equal to this, and every other number. But the catch is we cannot change them back to their original thing. And also, if the last elements are same, I guess we can make the whole thing same. Just if the last elements are same, I guess we can make the whole thing same, no matter what the other things are. Actually draw. Yep, right there. Okay, this is what we have, and we can change this into a 2. That makes sense. So this is equal, then this would be equal. How do we change anything else? And also, when we have numbers here, a1, a2, a3, a4, a5, and then we have other numbers b1, b2, b3, b4, before b5. This number can only be changed to whatever the value is for this number. And yep, and then this number can only be changed to whatever the value is for this number, and this number can only be changed to this, and this can only be changed to this. So whatever the value is here, it can, if you want, trickle down this whole list. That makes sense. And if at any point we have two things similar to each other, shit, yes, this 3 can become, yeah, if at any point we have two numbers equal to each other, we can trickle down this 3 onto here, here, and here, and then this 3 can also trickle down here, here, and here. Makes sense. And this, we cannot do anything else about these two, I suppose. Yes. And yes, yes, that would be it. And yeah, so answer for the fourth one would be 4, I suppose. It is 4. So whenever we see two numbers equal to each other, everything to the left of them can be matched. Here, 1, everything to the left can be matched. Okay, makes sense. Here, answer would be 4 and 5, actually, 5, 5. And here we have nothing, literally nothing similar. And the answer is 2. Why would that be? Okay, so whenever two numbers are equal to each other, okay. And yes, similarly, this number can influence this number can influence this, and this number can influence this, and this can influence this. That is nice. That is nice. And then we have this problem. Okay. Here, these two are equal, so yeah, they don't do anything. And this can trickle down here till here. Makes sense. Since these numbers are not affected by anything that is on the left, they are only affected by whatever is on the right. We can go element by element from right to left. So let's say 5 and 4, that is our initial array. Here we cannot make anything equal to each other. So, okay, then on to the next one. Here also, we cannot do anything. Right, we cannot do anything. Makes sense. And then 3 and 1, right, we cannot do anything. And Okay, so you can also write down the possible values which we can have here. We can have here 3 or we can have here 5. But if we want 3, then we don't have to change the best solution which we have calculated for this part, which right now is 0. But if we wanted 5 here, we would have to make this into a 5, and that might affect our best possible solution. In this case, right, right. But going from right to left does make sense. And yes, whenever, okay, cool. And then 1 and 2 here, here. Can I have 2 here? Yes, I can actually have 2 here. 2 can come from here and then go there. So yes. And then 4 and 3. Can I have a 3 here? I can, but that changes this 2. Yep, that will change the 2 here. If we do have a 3 here, that 3 can only reach this point after going through this 2. Shit. Since this 3, or we can also delete a whole thing. But okay, before putting in or yes, before adding this deleting a row operation, should be a pattern into what values, whenever we add a new column, what values these x and y can have, and what would be the consequences of having those values here. I think that makes sense. 1 and 1 makes sense. Cool. Okay. When we just have 5, when we just have 5 and 2, yep, answer is 0. And we are saying for, yes, let's say we will have 2 maps, one for possible x values and one for possible y values, and we will say if you want this current value at this current x or y, then we will have to, yeah, then the best possible answer would be this, or yeah, whatever. Okay, so here the current best possible answer, which is the maximum number of matches, it is 0 right now. And here, when we processed 5 and 2, we'll say this 2 can go here on the next step, and this 5 can go here on the next step. So, um, yes, we'll say that if we want a 2 here, or yeah, if we want a 2 here, then the best possible answer would be 0. And if you want a 3 here, then the best possible answer would be 0. Makes sense. And why are we doing this? Because we are listing out the choices which we can have for this current element. And here we have 4. Okay. And 3. Okay. And none of them is like the best choice. And okay, for y, we will say we can have 5 here, and the best possible answer for that would be 0. And we can have 4 here, and the best possible answer for that would be 0, right? And then move on to 1 and 1. here we can have 4, both of these values, 5 or 4, or we could just stay with 1 and the best answer would be 1. That does make sense. That does make sense. And shit, we don't want just two numbers to be equal to each other. We want either this and this equal to shit. If we ever have something like here we have 2, 2, whenever we have two numbers equal to each other, we can change the whole thing on to the left and make them equal to each other. But we don't need to fix this other number to be these two numbers to be at the same place like this, like they are right now, because this one could have been made one if it was here or here. So if we have this number equal to this, any other number here, then that would be a nice thing to have. We can actually split these numbers, I guess. 2, 1, 6, 5, 1, 4, 2, and here 3, 2, 6, 4, 1, 3, 2. Okay, and do we have matches? Yes, we do. 6 and 6 and 1 and 1. And we are looking 4, 5. This, yeah, shit. This was supposed to be a 5. This is a 5. I thought, wait, what? Yes, okay, so we have two vectors, makes sense, and the size is 10 power 5. Okay. Okay, let's split this one. In the top one, we will have 5, 2, 2, 6, 3, 10, 5, 10, yes, 7, and then 8. And in the second vector, second series, you could say, we have 6, 1, 3, 7, 4, 9, 5, 10, 7, 8. Should we messed up somewhere? 6, 1, 3, 6, 1, 3, right? 7, 4, 7, 4, 9, 5, 9, 5. Okay. So we messed up here on this one. 5, 2, 2, 6, 3, 10, 4. After 10 comes 4. 4, 1, 6, 9. Okay, cool. These are the two things, and we are looking for from the end. What is the choice where most of the numbers are same? I guess 10 is the rightmost element. Yeah, where everything is same on to the left. So the answer, we can easily make 1, 2, 3, 4, 5, 6 members equal to each other, match, but can we do something with the remaining ones? I guess not, because none of them are equal to each other. So answer for this one would be 6. I guess this is the fourth last, and the answer is 6. Okay. But okay, right. Yes, shit. Okay, that is it. That is it. We can split, and this would be it. Now, if that is all we had, then we could have written, we can write something to find the rightmost match in these two vectors. Here, the rightmost match has six numbers in the smaller vector. That is nice. But if we do a cut, now there are two things that we have to do. First is finding this rightmost match, right? And I guess we can begin by here and find the rightmost occurrence of 9 in this thing. Yes, the rightmost occurrence of 9 in this thing, which is doable. What are the values? Yeah, 10 by 5, we can write a map. We can write a map which will have the rightmost index for 9, and we can go through this whole thing, and yeah, finding the rightmost match for a given set of vectors will take n log n time in total. So yeah, that is doable. But then there is this extra operation which says we can remove a set of elements from this. And how would that affect everything else? Yeah, shit. How would that affect everything else? If we, let's say, chose this index 3 and 4 and we removed this thing, how would these two vectors change? Let's see. If we don't have 4 and 5, then what would these vectors look like? 5, 5, 2, 2, 6, then 9 instead of 3, 9, 5, 10, 10, 7, 9, 10, 7, 8. That would be one vector, and the other one would start at 6, 1, 3, 7, 10, 4, 1, 7, 9. Okay, this would be the other pair of vector if we chose to do our operation on this thing. And doing this operation does not affect anything on the right. It only affects the things onto the left. And okay, it only affects things onto the left. Makes sense. And okay, this was our original thing. But now, since we removed 3 and 4, after 6 we had 4, but now 7 goes here and 9 goes here, and things are changed. Things have been flipped. Okay, things have been flipped. And how does that affect our answer? This only affects things on the left and not on the right. This only affects things on the left and not on the right. So what we can do is, when we are at this 3 and 4 index, we can ask, when we are at this 3 index, we are looking for the last occurrence of this 3. Yes, if we do go with 3, then this is our best answer, which is 3 here. But if we choose to remove 3 and 4, our new thing would be this. And we look for this thing because, yeah, yes, we will look. Okay, this whole thing goes up there, and this whole thing comes down here, right? So should this changes the answer for everyone? This does change the answer for everyone. but this only changes the answer for this and this and this and this. That would mean we had something like this and we chose to remove two elements. Let's say this one and this one. Yes, we chose to remove these two elements. Then whose answer is changing? For which things is the value changing? We still have our 5, 2, 2, 6 on to the left of this 9 that we removed, and on to the right we have 5, 10, 7, 8, and in the second vector 6, 1, 3, 7. And yes, let me send the link of the question so that if someone wants to solve, they can solve. And on the right we have 4, 1, 7, 9. Okay, and when we made the decision to remove these two elements 9 and 10, originally this vector was like this, but then these would flip their position and this would be our new vector, and we are looking for the same thing here. Okay, these have been flipped. This was all of these numbers were originally here and they were finding their match among all of these numbers, but now this pair of number is finding their match among all of, well, again, these numbers, but these numbers instead of these numbers. Okay, okay. So this is the only pair which is changing with respect to this pair. Okay, okay. So for any of the numbers here, this can go with any of the numbers here, but also with any of the numbers here, it seems. So if we just find, let's say this looked like here instead of a 1, we had a 7. Shit, okay, to have a 7, to make this 7 go up, we have to remove the element to the right to here. So yeah, the first range would be all the elements in the second vector, and the other range would be all the elements here till 1 minus. Which we can do, which we can do actually. Okay, this is doable. Okay, this makes sense. We can do this. We will have like two maps. Yes, one we will pre-calculate, and the other map we will keep in implementing as we move forward. Yeah. A size n and B size n reference x a. Okay, and now we need two maps. And like, yes, what are the values? The values are in the range n. So values are not very big. Values are not very big. Values are n. So we can actually, instead of using a map, we can use a vector. So if we, let's say we go through the array A, and for each element we are looking for the last occurrence of this element. Okay. And also in its own, let's say for 6, we are looking for the last occurrence of this 6, but also in its own vector, we are looking for the last occurrence of 6. Last occurrence of 6 starting not here, to the left of this, just not here. That is the only place which is left in this. Okay, let's make the array for B. Okay, instead of using a map, we will use a vector, and we will say vector int index A size n plus 1, because the numbers can be from 1 to n, makes sense. And then index B, let's say size would be n plus 1. Yeah, and for int I equals 0, I less than n, I plus plus, and in B, bi equals I. We are saying that we saw the number bi last at the index I, makes sense. And then for int I equals 0, I less than and I plus plus, and we'll say int best equals 0. And when we are at a current element, we are looking for the last appearance of this number in the second. We don't have the two vectors. Shit. First, we have to create the two vectors, and this is not what we are looking for. Vector int links link A, let's say, and link B size n, and I equals 0, I less than n, I plus plus. Yeah, they will keep switching. If I is odd, let's say if I is odd, then link A I would be equal to AI, and link BI would be equal to BI, else link AI equals BI and link BI equals AI. That does make sense, but that has to happen before, after we fill in A and B. Okay, we have links, right? Now for int I equals 0, I less than n, I plus plus, we'll say int index B link B I equals I. We are saying the index in the B vector, which doesn't actually mean anything. The last time that we saw the value at position link bi was at position I. If that makes sense, that is like very cool. Okay. I equals 0, I less than n, I 0, 0. And yeah, so we are looking for best equals maximum of the current value of best, or when we are looking for link AI, the last index that we saw link AI at. We'll say initially the values should not be 0, they should actually be like -1. -1 makes a lot of sense. Link A, yeah, the last time that we saw this value, link A and link B, that would be index in B for link AI. And not just the index, but +1, right? And now, if we are looking in the same vector, so if I is greater than 1, or if I, yeah, okay, this step will come later on, but yeah, if I is greater than 1, then there is at least something at index I minus 2, yes, and we'll do the same step here. If we were to remove the elements at the last place, then this is what we will have. But instead of looking at index in B, we are looking for index in A. So this will become A, index A. And after going through a thing, if there is a element at the last place, we'll do index A. The last time that we saw the element at link I was at I. Shit, but yes, this could be somewhere that we don't know. So minimum of this or I. And here also we'll do the same, minimum of this and I. I think that is correct. See out best. That should hopefully have worked. Okay, shit. Okay, that almost did work, which is kind of crazy. Shit, okay, we got wrong answer in fourth. In this one, we got wrong answer. Answer is 4. Yes, 4 is the answer here. Why would someone say 5? Why would someone say 5 when the answer is 4? Okay, 5 does not even make sense. If 5 does not make sense. Let's output best. Yeah, let's output best and say we have just one test case, which is this one. One, okay, 1 is wrong. 1 is wrong. We are minimum. Take the minimum. Take the minimum. Right. And by default, every value there is -1. This -1 means -1. Makes sense. Yes. Okay, so first of all, clearly this -1 is wrong. One test case, which is this. Okay, we should not have 1 here because 1 does not make sense. Link A, link B. Let's say we are printing both of these. Compile one test case which has 6 numbers, which are these. Okay, first was 5, 3, 5, 2, 3, 4, 4. Cool. And the second one was 5, 2, 5, 2, 5, 1, 3, 6, 6. Uh, ah, when did answer become equal to 5 and why was it ever equal to 1? Minimum. For I equals 0, we won't go into this condition in neither of these two conditions. So answer initially, which was equal to best, best was equal to 0. It became equal to 1 on this line somehow. One test case, 6 numbers, which are these, and let's see. And we are going through link A, and link A we printed first, which is this one. This is link A, and we are okay. That is correct actually. That is correct. Okay, shit. That is actually not very wrong. If we can change this, if we can change this, and this, and make this thing equal to 3, 3, yeah, makes sense. Yeah, this is correct. So 1 is correct, and then saying that the answer is 2 is also correct. Yes, because these two numbers are equal to each other, and we can make these all of them equal to each other. So that is nice. And then for this one also, the answer is 2, which is okay. And then here the answer is 4, which is yes, as much as we can expect. And then here the answer is also ah shit. Okay, I messed up here. -1 equals we are not adding the current thing, but yeah, the previous one. Bingo. Okay. Okay. Like that is actually cool. That is actually cool. Okay. Let's see if this is correct. And before submitting, I just want to rewrite the whole solution. And this works. That is just amazing. Int n, taken n, vector int a, size n, b, size n. Yep. For int reference x and a, c in x, find a, replace with b. And we will have a bunch of other vectors. Link a, yes, why not? Size would be n and link b, size would be n. Let's fill these two, and these two represent the list of values which can affect each other. for int I equals 0, I less than n, I plus plus, and these alternate the ith value. And if we are for the ith value, if we are taking for link A from A and link B, B's ith value is equal to the link is equal to the ith value in B, then the I plus 1th value in link A would be from the vector B, and in link B, the I plus 1th value would be from A. So we just have to alternate. If I is odd, then link A I equals AI, and link V I equals V I, and else link check. What we can do, okay, this is cool. This is actually cool. So what we can do is if they are even, then okay, we can let them be. But if I is odd, then we will say link A, or we will say swap link A and link B I and share. This is actually cool. This is so cool. Shit. This is cool. This is cool. This is elegant. I would say this is elegant. Okay. And now we need a vector for keeping track of what were the values we saw the last. We need two vectors, one for A and one for B. And at this point, A and B are intermixed, so we are just using A and B as placeholders. So index IDX index A n plus 1, and index IDX B n plus 1. For int I equals 0, I less than n, I plus plus, and IDX B link B I equals I. And this is saying the last index that we saw, this link B ith element was at index I, if that makes sense. And then for the final answer, int best equals 0. And also, if we didn't see anything in here in the index, then we will say that its index is -1. Right. For int I equals 0, I less than n, I plus plus. Right. And best, not burst, best equals maximum of the current value or last value of best, and minimum of I, comma, best I, comma, not best, IDX index in B that we saw the element link AI. And whatever the maximum is, minimum is, add 1 to that. Yeah, so best is now best. And if I is greater than 1, then we can also look in the same vector for the best match, maximum best, comma, minimum of I, comma, IDX B, IDX A, yes, link AI plus 1 plus 1. And if I is non-zero, then we will put the last element in I, link I, into IDX A. IDX A, the last time that we saw the element link I minus 1 was at index I minus 1. And then we will have the best value, or maybe not. We messed up somewhere. Yes. And even, we could say this, yeah. And here give, and if I, then add the last number. Okay, why does this fail? Why do we say 0? Did you mess up in like this fancy method? Link AI and link BI. Swap these two values. And in here, wait, what? The second one should answer should be 3, but we are not saying that it is 3. See out link A. Yep, after forming the links, see out link A and link B. Let's see. Here we are saying that the answer is 0, which seems to be correct. 0 seems to be correct, but uh, 2, 2, 5, 5, 6, 6, right? And then 3, 1, 4. But what we can also do is flip everything over. The last time that we saw, the last element was at index I minus 1. Best initially equals 0, I smaller than n, and best equals maximum of best or minimum of index bi link I link ai. Yes, with the second thing could be 0 or it could be higher. Whatever the case, we will add 1 to the smaller of the two, and index a idx a idx index a link a, the last time that we saw link a, and yes, the last time that we saw link a. Okay, we have to change a few things here. Yes, that is better. As for link a, we are looking for the ith element in link a, which could be -1, correct? And then output best. Now, this should actually be working. But this is 0 in the second answer, which is crazy. Best equals 0. Okay. Why would the answer be 0? Shit, answer is not 0. Answer is 3 for the second test case. So this doesn't really make a lot of sense. Best equals 0, maximum, best, minimum of either I or the last time that we saw this current element, which is link A in B, in the list B, and add 1 to that. Okay, and if A, see out link A and link B. Yes. And if we are around here, then we can even look at elements here in our own vector. Should answer should be 3. Here, when we are at 4, we are able to see 4 here. So, y is the answer not equal to 3 in link A if I, which means if I is positive, non-negative. The last, see out, link A, I minus 1, space, and I. Compile one test case, and that one is this, the second test case. Okay, shit, one test case, which is this. Okay. Um, why did we never saw 4 there? We saw 2. This makes so much sense. This makes so much sense. Shit, this makes so much sense. Okay, this makes so much sense. Okay, okay, my bad. We can join anything whatsoever with each other. So when we are forming this, we will be doing if I greater than 1, then best equals maximum of best, comma, index x in B, the last time that we saw link, and yes, we won't be doing this. First of all, yes, we will be doing this. The last time we saw this value, the current link I value in B plus 1. And if I, then index B link B I minus 1 equals I minus 1. And when we are outside, we will say IDX B link B dot back equals n minus 1. And now, correct answer. Yes. And now I'm confident in this, that this would be correct. Let's see. Okay. In Q, and shit, this might just remain in Q and never come out of Q. That is one possibility. Yes. Shit, I am very stupid. My bad. Shit, the screen has been stuck. Someone might have told me in the chat. That would have been better. macOS screen capture. Shit, that was very stupid. My bad. And now we are on. That is nice. The screen is now visible. And yes, shit, the screen was stuck this whole time. That is actually crazy. But okay, here we are on test case 15. Hopefully, this is correct, and it seems to be correct. The time complexity is log of n, but it is using a lot of memory, which is fine, which is fine, which is fine. Yeah, cool. Accepted, and memory is also there, and that was a nice question. That was actually a nice question. Shit, that was actually nice. And now I would just like to go through the editorial for this question. And today I won't be streaming for long because I started late. My bad for that. I had no water in my house. It is like Dune, Arrakis giving our water to the dead or something. Lost soul. Shit, this was question number E in division 3. We are getting somewhere. That is nice. If we can get a match at position I, then we can have at least I matches. Why is this true? Because they can traverse throughout the left side of the array. For a certain position I, given the ability to remove index I plus 1. Okay, they are looking at if they can remove the index I plus 1. They are looking towards right. That is also an option. We can pull any value from the range. Okay, so they are going from right to left. I plus 2 to n. And then the solution. And before reading the solution, let's see the tags. So there are no tags. There are tags. And let me predict or guess the tags. I suppose the tags would be implementation and yeah, prefix, brute force, greedy. Yes, greedy. I always forget to say greedy because it seems like it is always there. Hello, how is everything going on? And today is a contest. That is crazy. Today is a contest. That will be actually crazy. And we just did this pretty cool question. And shit, I didn't remove this debugging code. It's anyway. Let's delete the whole thing and we will rewrite the solution again. Because this was a good question. N, taken N, cool, and vectors to store the whole thing. Reference X, A, C in X, find A, replace with B. And okay, we have the vectors. Now we need two other vectors. So we'll call them link A, size would be N, and link B, size would again be N for, and yeah, shit. Something is wrong with Vim. For int I equals 0, I less than N, I plus plus. We'll say link A equals AI and link BI equals BI. And if I is odd, we will say swap link AI and link BI. That makes sense because link A and link B are vectors where the values are linked in alternating order. That is, link A would have something like 2, 2, 5, 5, 6, 6, and link B would have 3, 1, 4, 3, 1, 4, something like that. So that is how we want them to be. I'm okay though. End of semester, my first semester is in like 20 days. Shit, shit. End of semester. Uh, okay, and you are in your first semester. You have a lot of time. You can like, yeah, mess around however you want. Vector of integers And yeah, like don't pay too much attention to college exams, I would say, and focus more on coding and stuff. Yeah. And also it is like relatively more difficult in first and second semesters because the college is more strict about these things, about attendance and stuff. Yeah. Index A size n plus 1 and index B size n plus 1, and for it I equals 0, I less than n, I plus plus, best, not bets, best answer equals 0 initially speaking. Okay, okay. Best answer equals 0 initially, and then if I my I greater than 1, then okay, shit, some okay. And I or best would be equal to maximum of best or a few other things. Yeah, maximum of best, or did we saw index B, in index B, the element link B ever before, and if we did add one to it, if I then index B link B I minus 1 equals I minus 1, and index B link B dot back equals n minus 1, and now we will start going through the A vector equal 0, I less than n, I plus plus, best equals, we will look in B, index B. When did we last saw the element link AI, or more correctly, best equals maximum of best, comma, minimum of I, comma, index B link AI plus 1. And also here we want to see minus 1. Cool. And this bit of code for checking in the same link. If I greater than 1, best equals maximum of best, or index B, index A link AI plus 1. And if I, then index, or yeah, index A link AI minus 1 equals I minus 1. See out best. Cool. It works, and that is actually cool. I was messing with C language, but it was great. Yes, it is great. The problem solving is good, and so some recommendation from where I should study it for college exams and for actual C. College is strict about 75% straight. Yeah, you can learn C from the C programming language book, second edition, ASCII edition, NC edition. This is the book from where I also learned C, the C language, and also this is, yeah, by these two people, Brian Kernighan and Dennis Ritchie. And I think this book is also called KNR because Kernighan and Ritchie, and Dennis Ritchie created the C programming language. He created the Unix operating system, and he's one of the good programmers. And Brian Kernighan has written a lot of books, and both of these used to work in Bell Labs when C was being formulated or something. around 1970s. And yes, they worked there for like 2 to 3 decades. Yeah, that book is nice. You can use that. The C programming language. And to the solution, it is clear to see if a match exists at position I, then we can repeatedly set the previous numbers equal to each other. Yes, for all j, where j starts at index I minus 1 and goes backwards until the start of the array. This allows us to have at least I matches, including the match at position I. Yes. Therefore, the optimal approach is to maximize index I where AI equals BI. Suppose we cannot remove any elements, then for some AI, we can set it to BI. Some AI, we can set it to BI such that J mod, their mod is not equal to each other, and J is on to the right of I, or set it to any AJ such that, okay, so like bring value from the right if there is currently not the value is not available. However, if you wanted to set AI to some BJ where J mod equals to each other, then we can just remove index I plus 1 from the array. By similar reasoning, we can, okay, they mean to say the same thing that we have done in like in their own way. Yes, it is the best book. And it is not just good for learning C++ or for learning the C language. It is good, the C programming language. It is good, period. I mean, if you go to the exercises after each chapter, there are exercises. I guess even between chapters, yes. Exercises. Run the Hello World program on your system. Experiment with leaving out parts of the program to see what error messages you get. So yes, they are telling you to play with the language, and that is very good when you are learning. And also the exercises are pretty cool. These were challenging for me the first time I was doing these, and yeah, these are like pretty good exercises. Look at this. Write a program to print the value of end of file. Shit. Verify that the expression get char is not equal to end of file is equal to 0 or 1. So here they are telling you that when you compare two things by not equal to, the value is not true and false, it is 0 or 1 because C does not have boolean. C++ has boolean, but C does not have boolean. And I guess the exercises at the end of the chapter were pretty challenging. Shit, the chapter is big. My bad. Yes. Here, write a program to check a C program for rudimentary syntax error like unmatched parentheses, brackets, and braces. Don't forget about quotes, both single and double, escape sequences, and comments. This program is hard if you do it in full generality. So they are telling you to write your own, not tree sitter, but kind of parser or something. You have to check if there is an opening bracket, there is another closing bracket after it, and that is crazy. You can use a stack for that. This is a good question. Write a program to remove all comments from a C program. Don't forget to handle quoted strings and characters, constants properly. C comments don't nest. So yes, this is a good book. And shit, let's maybe we can do one more question. But the thing is, today is also contest, and yes, today is also contest. And doing one more question might just take 1 more hour. So we can do some like I guess easier questions. Let's do some 1400 rated questions. At least one. At least one. Let's see. Uh, Saragara. Shit. The word Saraga is the abbreviation of Sarana Ola Raga. Okay, they removed this bit. an Indonesian term for a sports facility. It is created by taking prefix of some word and suffix of ga. Interestingly, it can also be created by prefix sa and raga. Okay, because raga ra is also here and here. Of the word olaraha raga. An abbreviation of two strings S and T is interesting if there are at least two different ways to split the abbreviation into two non-empty substrings such that the first, okay, you want to create an interesting abbreviation of a string S and T with minimum length, or determine if it is impossible to create an interesting abbreviation with minimum length. So we are looking for common things. Yeah, saga would be the one. And here E, B, nope, E. Yeah, this is okay, doable. Vim, something is wrong with my keyboard. S and T, and okay, my D, I guess, is not working at times. Yeah, this is like very similar to the question that we just did. And what is the maximum size? 200,000, 200,000. And okay. And what if the answer is not possible? If the answer is not possible, we will say -1. Okay. 200,000, and the string only has characters. A string, and they are not saying that the characters in the string are ASCII. So let's use a map int to int MP, and for auto CNT, but for int I equals 0, I less than n, I plus plus, and n does not exist yet. This dot st dot size, and we'll say np. The last time that we saw this ei character was at index I, right? When that is done, we will start moving I smaller than s dot size I plus plus. And best, we don't need the best. Yep. And yeah, if dot mp dot count, have we seen si before in the map? And if we have seen, then the current length would be I plus 1 plus n minus plus n minus 1 minus mpsi. And if clen is smaller than this dot size, or bool possible equals initially false, either this is smaller or not p, whatever the case, we will say p equals true. It is now possible. And And also, yeah, res equals or res dot insert res dot end or shit, string s res equals string s dot begin from the beginning till s dot begin plus I plus 1, and res plus equals string t dot begin begin plus I plus 1 comma t dot n. Output the response. Sara Nagara. Okay, that does not even make sense. Why do we say this? Is the length okay? The length I1 plus 1 2 from the current one, and n minus 1 n minus 1 n minus the index si in the map. Yes. Sara Raga. SAAHRAGA does not make sense. SAA. So initially it was empty for S, makes sense. Then for A, we did C A at I equal I at this location. So we should have SA, which we do have. T dot begin plus I plus 1. And okay, this makes sense. This should not be I, this should be MPSI. B A L. Why do we have L? B E L H I J A U. Okay, and the length is 1 2 3 1 2 3 1 2, which is 8, and here 1 2 3 1 2 3 and 1 2 8. Cool. And here also minus 1. So why does this minus 1 differ from R minus 1? Yes, if not P. Then, if not possible, then output -1. Else, output this. Cool. And 10 minutes might actually be too big, too long for this question. But let's see. Let's see how it goes. Damn. Yo. Yep, that book is actually pretty cool. And did you solve the lost? Yes, just now. By yes, lost soul. This was good. This was good. Lost soul. This was good. And yeah, I now just solve this 1400 rated question because I would be ending shortly because today is a contest. Shit. Okay. I guess I didn't solve this. So something is wrong. Something is wrong. Yes, makes sense. The thing that is wrong? Yes, we did this whole thing for these two strings. We also have to do this in like the opposite order. Yeah, here we will have a function which doesn't return anything. We'll call it func and doesn't even take anything. What does it need? It needs two strings which we will pass s and its string t and okay, LSB is on and res. Yes, let's send if res dot size, then this, otherwise this, and function s comma t and this, and then t comma s. Straight. Olana. Yeah, Olana is also correct. Olana is also correct. Water. Shit, we cannot do this in the opposite order. My bad. We cannot do this in the opposite order. My bad. Hello, how is everything going on? Yes, late. Yes, today is a contest. That would be crazy. And late because some things. Right. Yeah, I was late because there was no water in my house. Shit, we cannot do this in the opposite order. My bad. And yes, this is a 1400 rated question right here. Yeah, soul question. Lost soul was actually pretty cool. Something is wrong with Vim. Not that it is the reason that I'm facing difficulty. That would be a bad thing to say. Answer is correct, but I'm looking at the approach. Approach also seems to be correct. We are looking for the string with the with the minimum length. That is right. The only bad, seemingly bad thing that we are doing here is we are not going till the last element. An abbreviation of this is called interesting if into two non-empty substrings such that the first substring is a prefix of S. So we could also have had SA in this SA and A, like S from here and A, but then the second part would be yeah, non-available. Shit, makes so much sense. Shit, my bad. Uh, we are not just matching character. AR could be the thing that appears here. But if AR is appearing, A would be here and R would be here, and we would have this part and this part, which would have the same length as this and this, and actually taking this and this would be better. And this is 200,000, 5 zeros. And here the string is different, but the answer is correct. And here we say BERHIIJAU, JAU. And we say BEL. We start from here, and the length of both the strings is same, so that is cool. And yes, today is also a contest. Just resubmit, maybe something will come up. Okay, and fail on 7, I guess. P equals false. Right. I literally cannot see what could be wrong. Yes. Let's look at the test case, which is like unhonorable for GG. We said GG, but the correct answer is GG. Uh-huh. We look at the last occurrence. Right, right. Makes so much sense. Which is this. We cannot start from the first character here. And if we compile, we have one test case, GG, GG, GGG. Correct. Wait, triple G is, yeah, let's go. Gennady Golovkin, Triple G. Shit. Most commonly known, most commonly refers to the former professional boxer Gennady Golovkin. A friend of mine told me about him. Yeah, GGG, Triple G. That is what he's called. He's from Kazakhstani former professional boxer. GGG. Yeah. And there is also Alexander Karelin, who was like one of the best wrestlers ever to exist anywhere. Yes, I started late today. Yeah, I started late today. That is the reason. My bad for doing that. And also today's contest. Getting nervous and shit for the contest. Okay, this is probably going to work. And the question that we did before this was lost soul, and this was good. I mean, in hindsight, after solving the question, this like makes sense. Yeah, this makes sense. Test case 22, triple G, 24, 26, 28, 4 into 7, 3, 2, 3, 5, shit, 2 power 5, 32, shit, 2 into 17, yes, 2 into 17, prime, 37 is the prime. So this is actually fun. Shit, 3 into 13, prime, 41 is the prime, 41, yes, 41 is the prime, 41 is the prime. And accepted is accepted. And yes, 62 is 31 into 2. Breaking down numbers into their prime factors is cool. And yes, you can stop this. Yep, leave. And yeah, let's read the editorial for, or not the editorial, but let's see the, yeah, yes, what the solution is that they have written for lost soul. This was by Cry. Cry is nice. And shit, that is, I've seen this guy somewhere. Somewhere. And this person is from Egypt, was online 23 minutes ago, 2000 problems, and a lot of problems. I mean, like, yes, like much more than me. And 67 at this rating, that is cool. That is cool. And he has been here for about 2 years and 2 months, 1 year and 10 months. Okay, and using namespace std solve, taken n, taken the vectors, auto, I. Okay, yes. This is also something you can do. And vector bool scene a dot back equals a if the last elements are equal to each other. Okay, okay, yes, that is like you didn't even have to solve this edge case, but okay. And answer initially equals -1. That is much better. Hello, you are giving today's contest? Yes, today's contest. Yep, late today. My bad for that. And shit, I have to go to the washroom. I will be right back in just a minute. And today is a contest. Very scary. Today is a contest after a long time. I mean, I will be giving a contest today. That would be crazy. I am back. Will you be active during the contest on Discord? No. Why would I be on Discord while I'm giving a contest? No, I won't be. And how much math is required for machine learning? I would, well, it depends on how much you want to do, how much you want to get into machine learning. If you want to like just do things on the surface, you can use some surface things. I mean, I'm not too much into machine learning, but yes, you can train things using libraries. You can use sklearn, SQLite, or sklearn, I guess is the library. Yeah, ski, scikit learn. Yeah, you can use this for writing things. But yeah, depends on how much you want to get into the thing. There is a course of IIT Roorkee related to ML, and there are total 61 lectures, and one video is at least 30 minutes long. I mean, yeah, so you will be getting this much stronger, I would say. So yeah, that is good. And right now you are in school. So do not think in terms of time because you have a lot of time. So yeah, just go for it. And today's contest, shit. Even though I'm sitting bare feet, I'm shaking in my boots. And yes, let's this this for the submissions, there was this question, sum of Zor functions, and I want to see if I can see the solution which was submitted for this question by a stronger player. That would be nice, maybe by Mr. Tourist, if he did ever solve this question. D, sum of Zor functions. Shit, shit, bro solves hard questions. Shit, shit, error, shit. Time limit exceeded on pre-test 1. So bro doesn't even check locally. He just submits. Okay, we can filter by contest, and this was contest number 1879. Shit. Um, show unofficial. Move on the next page. And also, uh, yep, yeah, link L. All the best. Lin L. Yep, is a term for linear algebra. Shit, makes sense. Linear algebra, yeah, linear algebra. And for, I mean, for the basic things, there is always TB1 Brown videos. He has a series. Like these videos are amazing. Essence of calculus, linear algebra, alg, neural networks, literally neural networks, and differential equations. These are cool, very cool. And he has now recent videos on Laplace transformation. There's just so many things I want to understand and read. I Yeah, this is cool. And did Mr. Tourist ever give this contest? How can I see other people's? So yes, he yes, not my submissions, standings. Yes, Jiang Li's solution, education round 155. What? 155. Yep, cool. This is the one. Yep. sum of all functions, and that is nice. Let's see this. This is shit that uh shit. What was he up to? Main, he takes in the list. Let me bring up the question also. And also one more problem for today's contest is if I sub give wrong answer for the first question, I will have to go at the top of my house and jump off from there and then come back in front of my computer and then solve the question again. And shit. Or I could submit the right answer in first try. That would be more preferable. Okay. Uh, Here we do not have different test cases. N taken all the values. Okay, and the last one is empty. No, the last one is not empty. We are making a prefix of XOR. Okay, we are making a prefix of XOR. Okay, and then answer equals 0. And why does he have all of this boilerplate? Friend, constant expression, min, int, operator, minus, and I equals 0 and j 30. For each bit, he is going through all the elements and int I answer equals 0. Okay, z. This is of type z. Z is mint of type p. Okay, he has his own thing for doing things. Min integer. Shit, this will take time to go through. He has his own custom types, mlong and mint mod. Okay, this is something new. This is something new. And he added all of this boilerplate and his main solution grew small. Okay, great. Literally copy paste. We will submit the same thing. Or we'll submit from here. Shit. Go copy. Shit. Assert. Assert is not available. Yes, assert is not available. Makes sense because cd clibs, I guess. Yeah, bits db. Yeah, assert is not available because there is supposed to be a line. The place where from where my LSP is loading files is different. Doesn't know about the assert thing, and yes, it doesn't know. And if I go to plugins, the command which I'm calling for, yeah, compiling for C++, C++15, which is the GNU C compiler, and okay, dot local slash include. Dot local slash include. And here we have bits, std, C++, and which library has assert in C++. That is the question. Which year are you in? UT codes. I am in my third year right now. Yes. C assert. Okay. And now we will be happy. Emacs attach TCP run compile run. Okay. Oh, okay. This is what you will submit. Yes, literally copy paste and then submit the some observe functions. This is going to be fun to go through this, and I will go through this offline of the stream because I will be asking a lot of stupid questions while going through this code. This is cool, and then maybe I will explain this or try to explain this on a screen. Assert shape. Okay, where is this thing then? See, assert is here. Makes sense. Uh-huh. And the sum of XOR C++, and now there is no error because LSP has rerun uninitialized C++20 extension. Cool. And that would be it for today's stream. We did one tough question, which was not this one. This one was easy. Uh, which was the lost souls question. That was actually pretty cool. This one, lost soul. This was actually pretty cool. This is the solution that we came up with, and yeah, it works. It works. So that is nice. And today is a contest. So yes, I will be ending now. And that would be the end of today's stream. Today is short because there is a contest today. So we will see how that goes tomorrow. And thank you for being here. Bye.